Hi, dear professor. I am Mohammad Sharifullah. I hope you are doing well. I am going to explain the Cuda-based image processing homework. In this recording video, I will present my Cuda-based image processing project. The objective was to implement several image transformation in operations using GPU parallelism and apply them to PPM image files. Here I implemented 4 CUDA kernels like Gaussian blur, edge detection, color invention, and a function-based sine wave generator. And the PPM file format is a simple raw RGB format, like where each pixel is stored as 3 bytes, red, green, and blue. Because each pixel is independent, PPM images are ideal for GPU processing. CUDA allows launching thousands of threads where each thread handles exactly 1 pixel. This produces dramatic acceleration compared to CPU-based loops. So for this, for the pixel indexing formula, I use index equal like x plus y dot into width. I used a 2D grid and 2D block configuration so that CUDA thread corresponds to 1 pixel. The block size I used like 50 by 12, and the number of blocks was computed from the image dimensions. I allocated a memory on the GPU with CUDA malloc, and copied the input images with CUDA memory copy host to device. Like they are. CUDA malloc and the like CUDA memory copy host to device. For timing, I used CUDA events like CUDA event record, CUDA event record start, and CUDA event elapsed time like this one. This one. Okay. And here I already explained I used 4 strategies. The first one is Gaussian blur. Here each pixel is replaced by weighted average of itself and its neighbors. I used a 5 by 5 Gaussian kernel like this one, because blur is neighborhood based. Each thread checks pixel boundaries, passes neighbors, and accumulates weighted values. The second operation is like edge detection. Using central differences inside the kernel, each thread computes the gradient in X, like these two, and Y directions. If the magnitude exceeds a threshold, the pixel is marked white, otherwise it's black. Okay, the third one is on the function-based sine wave image. It's basically the third operation is not based on an input image. Instead, the kernel generates a sine wave pattern across the canvas. The formula is like this one. This one. And respective code is the there. This one, this part on the sine wave, this part. And the final and last one is my choice. I choice operation like color invention. Each pixel value is flipped using like this formula. This one, and it's change in the code like for red, green, and blue, like this one. This this one. Formula is there. Okay. This is very efficient since it's only like requires a simple arithmetic per pixel. Now I will show how I compile and run the code on UTC Sim Center. Okay. So this is my code. Okay. And then, so I ran the code for blur, first condition, Gaussian blur, and blur computed in like 83.85 millisecond. The next one is like age detection. The runtime is there. So rest of the do is like this. And when I run this code, I store like calculate all the values runtimes is there. This is all my runtimes, which show that performance under a thread per pixel workload. And for this, I use this figure is the original input image. So as our specific directly support upload an image, so I use um, Python for generating ppm data, and then I upload it to the sim center. Like if I check there, then this is the input ppm, where like in the input ppm all other like this sign ppm and other ones I run. If I then the edge ppm. Okay, so I um, upload it to the same center, and then after executing the code, I can download all the ppm data, and using these data points in like Python, I generate the images. So this is my Gaussian blur image, and that is for like age detection, and this one is sign image, and the last one is like the my choice inverted color option. Okay, so um Finally, in this assignment, I demonstrate how to perform GPU parallel image processing using Cuda in our species center. Its operation mapped directly to pixel level parallelism, making Cuda a natural fit. This assignment teach me memory management, kernel design, GPU timing, and how to run CUDA programs on SPC cluster. That's all about my presentation.